Hello everyone. Before starting the lesson, try this warm-up. Factor this expression and complete the square for this expression. Pause the video and try it. For this expression that we're factoring, I look for a greatest common factor and I don't see one. So this is a complex trinomial. 3 times 8 is 24. So I need two numbers that multiply to 24 and add to -10. Well, that's -4 and -6. So I decompose the middle term, then I factor by grouping, and I end up with this. And when we complete the square, remember, group the two terms that contain an x, factor out the leading coefficient. To make the perfect square trinomial, we have to take half of this number and then square it. So half of -6 is -3, squared is 9. So add 9, but then take it away so you don't change the equation. Now this perfect square trinomial factors to this, x minus 3 squared. That -9 is still there. Now expand, you get this, and then simplify your like terms. We end up with this. So these are two skills that we're going to use in this lesson, factoring and completing the square. We're going to be solving quadratic equations. So we're going to solve problems involving quadratic functions. And we're going to determine the number of zeros, or x-intercepts, or roots, of a quadratic function. Now, if you're asked to solve an equation in this form, there's basically 3 ways that you can solve an equation like that. You can graph it and find the x-intercepts, or the zeros. You can factor the equation and solve, or you can use the quadratic formula. So we're going to look at all 3 ways in this lesson. We're not going to spend much time on solving by graphing, but I will touch on it. So here's my first example. We're going to solve this equation by factoring. Now before we get to that, here's how we would solve this by graphing. I would take this equation that's equal to 0, and I would turn it into a function. Graph the function f of x equals 25x squared minus 36. So I'm just going to graph this. And to solve the equation, well, I'm trying to find when this function is equal to 0. So where is it equal to 0? Here and here, in those 2 different spots. The x-intercepts on the graph show me what the zeros are. They show me what the answers are for this equation equal to 0. So I can see that my answers are going to be -1.2 and +1.2. So when I solve by factoring, I'm going to get those same answers, or at least I should. Now this is a difference of squares, so I end up with 5x plus 6 times 5x minus 6 as the factored form. Now how do I solve this by factoring? Well, remember the zero product property. This factor multiplied by this factor equals 0. So either 5x plus 6 equals 0 or 5x minus 6 equals 0. So in the first case, to solve for x, I have to subtract 6 and then divide by 5. And in the second instance, when 5x minus 6 equals 0, to solve for x, I have to add 6 and then divide by 5. So I can see I get 2 possible answers for x. X is either -6/5 or +6/5. Now you might be thinking, I thought it was -1.2 or +1.2. Well, it's the same thing. 6 divided by 5 is 1.2. So when I used Desmos graphing calculator, it gave me the decimal version of this answer. But I'm getting the same answer whether I solve by graphing or solve by factoring. Now to finish this off, to make it look nice, we're going to write it like this. X is equal to plus or minus 6/5. It's positive or negative, but it's the same fraction, 6/5. So I touched on solving by graphing. You just graph the function and find where it equals 0, because that's what you're trying to solve for when the equation equals 0. Or if you're solving by factoring, then you just factor the equation. And once you have factored form, you use that zero product property to solve for x. So you may have 2 different answers, and you would just write both as possible answers for x. Now in this example, I'm asking to solve by factoring again. So we're going to have to factor, but watch out, before you start factoring, look at the way the equation is written. Is it equal to 0? No, this is equal to 20. I need to make sure my equations always equal 0. So to make this equation equal to 0, I have to subtract 20 from this side. And if I subtract 20 to get down to 0, I have to do the same thing to the other side. So once I do that, I end up with 3x squared plus 7x minus 20 equals 0. Now I can factor this and solve the equation. So why don't you pause the video, factor the equation, and see if you can solve for x. In case you need a little help, remember, this is a complex trinomial, so we need numbers that multiply to 3 times negative 20, negative 60, and adds to positive 7. Here's some possibilities, but remember they have to multiply to become negative, so the signs can't be the same in your two numbers. One's plus, one's minus. So if you just needed this little reminder, you can pause the video and try the rest. So once you factor it, you end up with this. 3x minus 5 times x plus 4 equals 0. Now you can use that zero product property to solve. And when you do that, you get x equal to 5/3 or x is equal to negative 4. And we can write our final answer like this using set notation. That makes it look nice. If you had any questions about this, make sure you ask your questions before you move on to the next example. In the next phase of this lesson, we're going to talk about how to solve an equation using the quadratic formula. Now, it's very key to remember that this formula only works for equations written like this. Standard form equals 0. It has to equal 0 or else the whole thing falls apart. Now, before I go into the quadratic formula, I want to take you on a little tangent here. Just bear with me. I want to show you that we can solve an equation by completing the square. So here I have an equation, 0 equals 2x squared plus 16x minus 18. I can factor out the leading coefficient for the first two terms. I make a perfect square trinomial by taking half of 8, which is 4, and squaring it, which is 16. Got to add 16, but then take it away so I don't change the equation. Then I factor that perfect square trinomial to get x plus 4 squared. Then I expand. 2 times both terms in the brackets gets me this, and then I simplify my last two terms. And I end up with this, 2 times x plus 4 squared minus 50. So I've completed the square. Now I'm going to switch gears and start to actually solve the equation. So notice I'm trying to isolate for x, so I'm going to have to add 50. Now I have this. Next I have to divide by 2, which turns it into this equation. Now, got to do the opposite of squaring, which is the square root. But remember, it's the positive or negative square root that I actually am taking. Now to solve for x, I got to subtract 4. And I end up with this. Plus or minus root 25 is plus or minus 5. Subtract 4, I get negative 4 plus or minus 5 as my answer. So I end up with either negative 9 or positive 1. Negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. So those are my two possible answers for x. Now why am I going through this? I'm completing the square to solve this equation. Now imagine I did that for just the general form of the equation, ax squared plus bx plus c. If you were to complete the square, it would look like this, and then when you solve, you would end up with, you guessed it, the quadratic formula. If you want to go through this proof in detail, you can pause the video and take a long look at it. But really what I'm doing is I'm just completing the square. Factor out the lead coefficient. Half of this squared, add it, take it away. Factor the perfect square trinomial, expand, and simplify, and then start to solve. So you end up with the quadratic formula, and that's what we're going to focus on. So this is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Of course, a, b, and c, wherever you see it in the quadratic formula, corresponds to the numbers you would have in the a, b, and c positions in the general form of the equation. And I'll just remind you, the equation must equal 0 before you start plugging numbers into the quadratic formula. The quadratic formula is useful for equations that you can't factor. If you can solve by factoring, you can still solve by factoring, but if you can't, try the quadratic formula. So here's another example. Solve using the quadratic formula. Get an exact answer. Well, I hope you noticed this. This equation is not equal to 0, it's equal to 30. So how do we change the equation so that it is equal to 0? Yeah, we have to subtract 30. And when you do that, you end up with this. 0 is equal to negative 5t squared plus 30t minus 20. Now, I just want to show you here, I could try to solve by factoring, and I would notice that I have a greatest common factor with negative 5, and the other factor would have to be t squared minus 6t plus 4. This looks like a simple trinomial, but if you try to factor this, you have to find two numbers that multiply to 4 and add to negative 6. And if you think through that, these are the possibilities that multiply to a positive number and add to a negative number. These multiply to 4, these multiply to 4, but none of these add up to negative 6. So this can't be factored any further. And so if you were to solve by factoring, you'd be stumped. You wouldn't be able to solve for this. But thank goodness we have the quadratic formula. And just remember, this is the formula up here. Negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now that's x. We have t. That's fine. It's interchangeable. So now we just have to figure out what numbers to plug into the a, b, and c spots in the formula. Well, we could start with this equation and say a is negative 5, b is positive 30, and c is negative 20. Or, to make our numbers a little smaller so that it's easier to work with, we can just look at this part here. Because, look at this, negative 5 multiplied by this equals 0. Well, I know negative 5 is not 0, so that means this must equal 0. So essentially, t squared minus 6t plus 4 equals 0. So the answer to this is the same as the answer to this. This one has nicer numbers, so I'm going to use that. So my a value is 1, b is negative 6, and c is 4. And I'm going to plug these numbers into the quadratic formula. So negative b is negative 6, plus or minus the square root of, b squared, so negative 6 squared minus 4 times a times c, 4 times 1 times 4. Divide by 2a, well, a is 1, so it's 2 times 1. Now clean this up a little bit, and we end up with this. Negative 6 is just 6. This is 36 minus 4 times 1 times 4, which is 16. So we've got 36 minus 16, that's 20, and 2 times 1 is 2. So I've got t is equal to 6 plus or minus the square root of 20 divided by 2. Now that is an exact answer, which is what we're asked to get, but let's simplify this as much as we can. We can simplify the radical. The square root of 20 is the same as the square root of 4 times 5, and the square root of 4 is 2, so that's 2 root 5. So I've got 6 plus or minus 2 root 5 divided by 2. Now let's factor this. There's a common factor of 2 here. So I have 2 times 3 plus root 5 divided by 2. Now I have 2 and 2 as factors in the numerator and denominator. So they cancel each other out, and I'm left with t is equal to 3 plus or minus the square root of 5. And I can't get more exact than that. So that's it. Just to recap, if you're going to solve an equation using the quadratic formula, it has to equal 0 first, and then you have to figure out what your a, b, and c values are and plug them into your quadratic formula. Once you have done that, it's just a matter of simplifying as much as you can, and then you end up with your exact answer. Now this is pretty much the same thing, except we're starting with a different equation, and it doesn't look nice, but if you expand and simplify this and make it equal to 0, then you'll have what you need in order to solve using the quadratic formula. So why don't you try this? Expand and simplify everything first, and then make the equation equal to 0. Then you can use the quadratic formula. Pause the video and try it. So once you've expanded and simplified, you'll end up with this. Now you're ready to use the quadratic formula. So a is 5, b is negative 18, and c is negative 9. And I can plug those values into the quadratic formula. So that's 18 plus or minus the square root of 504, all of that divided by 10. But I can simplify this more. 504 is 36 times 14. Remember, 36 is one of those perfect squares, and it's the highest perfect square factor of 504. And square root of 36 is 6, so I have 18 plus or minus 6 root 14 divided by 10. Well, I can simplify this even more. The greatest common factor of the numerator is 6. And the fraction 6/10 reduces to 3/5. So my final answer is x equals 3 times 3 plus or minus root 14 divided by 5. That's my exact answer. I could keep going and get an approximate answer, but the question asked me for an exact answer, so I'm going to stop here. That's as simplified as I can get it. Now just another note about the quadratic formula. The discriminant is the part of the quadratic formula that tells us how many solutions or zeros an equation will have. This is the part I'm talking about, the part that's underneath the square root sign. b squared minus 4ac is called the discriminant. Now if that discriminant is greater than 0, if we get a value greater than 0, a positive number, we're going to have two solutions, because we're going to take the positive and the negative square root of that value. So we have to do the calculation twice through. We'll get two different answers for x. Now, if that discriminant is equal to 0, then we're only going to have one solution to our equation, because if you add the square root of 0 or you subtract the square root of 0, well, adding 0 and subtracting 0 gets you the same thing. So you're going to get one answer for x. But if that discriminant is less than 0 or negative, well, you can't take the square root of a negative value, so you're going to get a math error. All this simply means is that there are 0 solutions. There's no real numbers that give you an answer to that equation. So just keep this in mind. If the discriminant, the value underneath your square root, is positive, you're going to have two possible answers for x. If it's 0, you're going to have one answer for x. And if it's negative, you're not going to have any answers. You just can't solve that equation. So let's figure out an answer to this problem. A market researcher predicted that the profit function for the first year of a new business would be p of x is equal to negative 0.3x squared plus 3x minus 15, where x is based on the number of items produced. Will it be possible for the business to break even in its first year? In order to answer this question, you need to be understanding a couple things. First, you need to know what break even means. In a business context, to break even is to not make money, but not lose money. Your profit, which is the amount of money you're making, your profit would be 0 if you're breaking even. So when you read this question and it's asking about breaking even, you have to understand that that means your profit is equal to 0. Profit is p of x. The profit as a function of x. X is the number of items produced. Notice the question also is not asking you how many items would need to be produced in order to break even. It's just asking, will it be possible for the business to break even? So we know the profit is 0, and here's the function. We could solve for x to figure out how many items would need to be sold in order to have a profit of 0. But it's just asking, will it be possible? So really, we just need to know if there are going to be any solutions to this equation. Really, we're just seeing what the value of the discriminant is. If we can calculate the value of the discriminant, we can figure out whether we're going to have a solution or not to this equation. So b is 3, a is negative 0.3, c is negative 15. So the discriminant is equal to this, which equals negative 9. So I don't even have to use the quadratic formula. I can see the discriminant is negative. So if I tried to take the square root of that, I wouldn't be able to get an answer. So because the discriminant is negative, I know there's no solution to this equation. And because there's no solution to the equation, I can say it's not possible for the business to break even. Because there's no way to solve this equation, there's no way that they're going to make it happen. So it's not possible. And a final challenge for you. I did this earlier, but see if you can do this on your own. Solve ax squared plus bx plus c equals 0 by completing the square in order to develop the quadratic formula. If you're up for that challenge and you really want to try it, you can pause the video, try it on your own, and see if you can do it. If you want to find the answer to this, you can actually just go back in the video and you can find the solution to that. Otherwise, it's time to practice. So you've got some practice questions that go along with this lesson. Remember, you can solve a quadratic equation either by graphing, by factoring, or using the quadratic formula. In any case, make sure your equation equals 0 before you start to solve. If you need help with any of this, please reach out and I'll do my best to help.